Hello everyone and welcome to the part 4 of this video series under sets. If you missed the previous part of this video, kindly check the description of this video. You'll find the link to this to other part of this video. If you are yet to subscribe to PA Academy, please click the subscribe button to subscribe to our channel and this little bell icon beside the subscribe button. So in this part 4 of this video, we are going to be looking at the Venn diagram, the union of sets, intersection of sets, and complement of a set. So when we talk about Venn diagram, he said this shows the relationship was between sets. In subsequent part of this video, we are going to be solving examples that deals with Venn diagram. Then we are going to understand that's proper. But another important thing we need to know when we talk about Venn diagram or sets is what is union of a set, intersection of set, and complement of a set. So when we talk about the union of a set, he said it is denoted with the symbol like a U. U, look at it. So just this is the symbol for union. Like this. So this is the symbol for union. Said it is denoted with this symbol. He said so when you talk about union of a set, said in a set A and set B, the collection of all elements in A and B or both is called union of sets. So this is written as A union B and pronounced as A union B. So this is how you write it. And so this is how it looks like if you have to draw it in a pictorial view of union of a set. So if you don't understand, let's still look at this example, for instance. So if you have these two sets as an example, we have set A, 1, 2, 3, 6, and 10. We have set B, 2, 4, 6, 8, 10. Now, if you are asked to look for the union of these two sets, that means you bring all the elements together. That's what I wrote. I said I was. It is the collection of all elements in A and B or both. So that's what we mean by union. So once you bring all the elements together, so that means A union B will give us 1, 2, 3, 4, 6, 8, and 10. So all the elements in A and B, once we bring them together, look at for set A now, we have 1, 2, 3, 6, and 10. Now let's look at the union. 1, 2, 3, 6, and 10. For B, for set B now, we have 2, 4, 6, 8, 10. Let's look at it, maybe it's present in the union. That's 2, 4, 6, 8, 10. So that's what we mean by what? By union of a set. You bring all the elements of that set, you bring them together. Now, it's also important to know that if the two sets, for instance, now you see set A and B, 6 is common to both sets, 10 is common to both sets, even 2 is also common to both sets. So you will not say because 2 is common or 6 is common and 10 is common, you write them two times. No, you just write them once. You write them once. So that you're only having 2 once. 6 is only once, 10 is only once. So you don't write them multiple times because they appear on both sets. So you want just pick one and then you have it in the union of the set. So that's what we mean when we talk about what the union of a set. Say that what in a set A and set B, the collection of all elements in A and B or both is called the union of a set. Now in this example, I just use two sets. That is set A and B. So sometimes we can also have a set C, and then we'll be asked to look for the union of A union B and A union C. So you can also find questions like this also, having three different sets. So now let's go to the third one, which is intersection of a set. Don't forget the other one we look at the union. Now we are looking at intersection of of sets. So from the word when we look at intersection, it said in a set A and B, the collection of elements which belongs to both set A and set B is intersection of set A and B. So this time around, it is denoted with this symbol. This is the symbol for intersection. It said it is denoted as this symbol written as A intersection B. So this is the symbol for intersection, like this. This is intersection, so don't mix it up. Intersection. Why this is union. So just know when we talk about union is U, so you should know that union U, then intersection, the second at the N, and this is N intersection. So it is written as what A and then the symbol and B, pronounced as A intersection B. So this is the pictorial representation of the intersection of sets. So you can see that the parts where A and B meet. So the part that belongs to both A and B, that's intersection. This shaded part, that is intersection. So let's use this example to explain it. Now, let's look at these two sets A and B. These are the elements in set A, and these are the elements in set B. Now, if you're asked to look for the intersection of set A and set B, which is this, that is A intersection B. That means the elements that is common to both sets. Come again, elements that you find in set A and you can also find in set B, that is the intersection. And it is 1, 3, 5. Look at it. 1 is common to set A and set B. You can 2 is in set B, but is not in set A. But 3 is common to both sets. Look at it. 3. We have 5 in set A. We also have 5 in set B. So you can see that they are common to both sets. Then every other number, we have 4 in set B, but we don't have it in set A. 7 and 10 is only present in set A, not in set B. So that is what we mean by intersection. Elements that are common to both sets. That's what we mean by intersection. And like I said when we are looking at union, you can also have C. You can also have a set C, then whereby you have to look for the A intersection B and intersection C. So now let's assume our set C, we're having element of 2, 4, 5, and 7 as the elements in set C. Then if you are to look for A intersection B intersection C, then the answer will be 5. So that will give us 5 is a singleton set. That's because 5 is common to what? 5 is there, 5 is there, 5. That's the only elements that is common to the 3 sets. That will give us 5. So whichever way the question is, just know that when you talk about intersection, you are talking about elements that is common to the sets that you are comparing. Either there are 2 sets, or there are 3, or there are 4. Once you just look for the elements that are common to the sets, and that will give you what? The intersection of the sets that you are looking for. So now let's look at the complement of a set. This is also a very important one when we are looking at sets or Venn diagram generally. They said complement of a set. Said these are elements in the universal set that are not in the set related to the universal set. This is what it means. Say, let's say the universal set U is 1 to 10. We have the universal set as 1 to 10. Let me just be writing it here. So if we have the universal set as 1 to 10, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now this is the universal set. And our A, this is our A. So our set A is 2, 4, 6, 8, 9, and 10. Now, so when you are asked to look for the complement of set A, if you are asked to look for the complement of set A, the complement of set A, this is the symbol, complement of that will be A raised to power 1. We call it A prime. This is it. It's denoted as A raised to power 1. They call it A prime. You don't call it A raised to power 1. You call it A prime. Now, if you are asked to look for the complement of set A, what they mean is that you look for all the elements that is in the universal set that is not in that set. That is set A. Come again. Now, when we are looking for the complement of set A, that means this is set A. Now, look at the set A and look at the universal set. Those elements that are present in the universal set that are not present in set A, that's what we mean by complement of a set. So if you have to look at set A and the number and the elements that are not present, if you look at set A and look at the universal set, what are the elements that are in the universal set that are not in set A? Look at it. 1. There's no 1 in the here. We have 2. Then 3. 3 is not in the in set A, but it's in universal set. Universal set is 1 to 10. So let's look at it. Then we have 4. 5. 5 is not in set A. 6. 6 is here. 7. 8, 9, and 10. So these are the elements that are in the universal set but are not in set A. That is what we mean by complement of what? Of a set. So, and this is the symbol A prime. So it might be any number. It might be sets. It might be set B. And if you are looking for the complement of set B, that will be B prime. So in course of I've been using set A, but it could be the set can be denoted with any alphabet, set A, B, M, or any alphabet. So that's what we mean by what complement of a set. The element that is in the universal set that is not in that set itself that you are looking for the complement. So that's what we mean by the complement of a set. So in the next part of this video, we have been looking at, I've been explaining a lot of things since. So we are going to, next part of this video, we are going to be looking at series of examples under set, under Venn diagram. So make sure if you have come this far in this video, in this video series, make sure you don't miss the next part of this video, because we are going to be looking at examples, different type of examples that you come across when it comes to sets. So I'll see you there, and please don't forget to subscribe to this channel, PA Academy, and then that is it. I'll bye for now.